Hello, good afternoon, everyone. My name is Garima Singh. I'm from IIMT College of Polytechnic from Department of Mechanical Engineering. And today we are going to discuss about shape memory alloys and their applications. So here, let's talk about some introduction of shape memory alloys. Shape memory alloys, in short, are called SMAs. And these are the part of smart materials. Now, what are smart materials? Smart materials are basically those materials which respond based on the experiences they have from their surroundings. SMA are the materials which have the ability to return to the predetermined shape when heated. So, it reacts when there is some force applied on it. And sometimes it gets to its predetermined shape after heat is applied on it. So it depends like what kind of smart material is that, or what kind of shape memory alloy is that. Now, the metals and alloys that exhibit the pseudo-elasticity and the shape memory effect are called shape memory alloys. The popular SMEs are NITI, CuZnAl, and CuAlNi. As you can see in the figure here, a person is heating up the wire, so the wire is getting coiled again. So if you straight it by applying a force, then after heating the wire again, it gets to its original form or original shape. That's how the shape memory alloys work. Here are some types of shape memory alloys. It can be distinguished into two parts, like one is stress-induced transformations and the other is temperature-induced transformations. So the stress-induced transformations are the effect by that is called pseudo-elastic effect. And due to the temperature, the transformation that occurs is called shape memory effect. The shape memory effect are of two types. That one is one-way SME, like one-way shape memory effect, and other is two-way SME. So let us discuss this more about this in the next slide. Okay, so here is a principle, like the basic principle of behind the SMEs is that a solid state phase occurs in these materials, like a change in the phase describes that which kind of structure does it have. The switch between the states of austenite and martensite. The SMAs has two stable phases. One is austenite, that is the high temperature phase of the material, and the other is martensite, that is the low temperature phase of the material. Here in the diagram, you can see the first figure is of the austenite. It is a high temperature phase and it has a cubic crystal structure, as you can see. Second is the martensite, that is a low temperature phase. It is a monoclinic structure and it has two different forms. Like first is twin martensite and the other is D-twin martensite. So this is the transformation that occurs after applying the force or after the deformation. It D-twin the martensite structure on application of heat. So let us discuss like how does it happen. In this particular slide, you can see that in the first like one-way memory effect, what happens when austenite is cooled, it creates a twin martensite. And after deformation, the D-twinned martensite is occurred. But when we heat again the D-twinned martensite structure of a solid, it again returns back to the austenite structure. This kind of effect is called one-way memory effect. Now, the other is two-way memory effect, in which an austenite structure on cooling gets to the twin martensite structure. And on heating again, it goes to the heating, like on heating again, it goes from D-twin martensite structure to the austenite structure again. So what happens in this? When we apply the force, there is a change in the structure. But if we want to convert this shape of the solid back to its original form, we just need to apply the heat in this. So that's how these works. Here are some examples of the application of SMAs. In the medical, we have catheters, medical guided wires, bone plates, and stents, and other application where the safe memory alloys can be used because there are some areas where we can use this application like shape memory of the object so that it can replicate the human structure or the void or the real structure that should be there in the first place. Second, these are also used in aircrafts like the wings, engines, stabilizers, landing gears, and others. So that due to any deformation just after application of some kind of heat, the structure or the solids can get its shape back and there won't be any damage due to that. And the third application is for civil engineering, in which we can have the applications in reinforcing materials, damping devices, structural connection, isolation devices, and frames. In automotive areas, body frame, engine, battery, and other applications are there where we can use or see the applications of SMAs. Here are some diagrams where the real SMEs are used. You can see the SMA wires, SMA cables, SMA bars, SMA helical springs, SMA washer springs, SMA ring springs. Then in the aeronauticals, we have solid state actuator, we have orthodontic wire, we have several other tools, we have self-expanding stands, then we have SMA bone staples, we have SMA art applications, we have SMA thin film, MEMS, then eyeglass frames that can regain its original structure by applying the force, and as we release the force, it regains its original structure. So that's an eyeglass frame. And then SMA dumper, then robotic applications are also there, which are very popular in SMEs. Now, basically, we use two kinds of SMAs. The first is copper-based alloys, and the other is nitinol. The copper-based alloys, they show the excellent conductivity. They have cheap cost, and they have higher resistance. But in the retinol, these are mostly used in actuators and sensors and heaters. So they are good at the heat conduction, and these are the both of them have different applications based on their the particular features. Now, the present use of SMA. In automobile, the SMA leads the actuator to do not require actuators do not require the bulky and complex mechanical design to function. The spring dampers, valves, etc. are made of SMA. Even though safe memory alloy actuation can provide significant advantages over the traditional gadgets in the automobile region. Then nitinol-based SMEs has great application in the area of microelectric mechanical systems, which are mechanical elements along with integrated sensors and actuators and electronics devices on regular silicon based through the silicon microfabrication. So both of these applications are the mechanical applications where we use the smart materials such as SMA to provide the better productivity and better results. Then the next application area is fixed wing aircraft and rotorcraft application. These smart wings are made up of active materials like SMA, and these are used to develop and demonstrate the optimized performance of lifting bodies. These SMA or SME are used as actuators by using shape recovery, which occurs at the non-zero stress. So what happens in this? Whenever there is a damaged aircraft wing, this material helps it to regain its own original structure just by application of some kind of stress or heat. So construction field, like what is the application in the construction field or civil engineering? The SMA has a great potential to enhance the civil engineering structures. Vibration suspension in civil engineering can be achieved by utilizing active control and semi-active control and passive control. Like how we use it, we use the like the suspension rates, or there are some areas where we need that if there is some damage due to the force application, that can be regained by its own, or you don't have to interfere that. So that kind of structures can be refilled, or we can use this kind of SMAs in that kind of construction fields. So now the next application is in biomedical. Since SMA has features like biocompatibility and biofunctionality, and it will not create any allergic reaction to the host surface, that is the skin. This is the main reason, uh, like to use in the field of medical sector. Like SMA based material like NITI is widely used in medical treatment. Now, why in biomedical devices or biomedical applications? Because those material which are biocompatible does not harm humans or any other human organ. So these kind of material, if they are capable of shape shifting, or you can say changing the shape, like recognizing their original shape and changing the shape after getting damaged to their original shapes, then that will be very beneficial for humans, because every human has a different structure. And if that particular human part is not available, or you can just add a biomedical device that is required at particular area of the human body. So if that will be the SMA, so what will happen? That particular area will get its original shape by its own. That will act as a smart material. That material will smartly get along with your body, and that will be a very biocompatible device for your human bodies. That is a boon for the human generation and hospital departments. Next is orthopedic SMA, such as atrial, septal, and orthodontic wires. Orthopedic staple and hand gloves play a vital role in medical sector. All these are examples of SMA materials which are right now presently widely used in our industries, and that these are helping a lot the human lives. Now, what are the future scope? The future scope of the SMA is far and behind our imagination. Actually, the heating and cooling, this kind of SMA materials are discovered and are presently used on a wide scale, but still there are very huge amount of population that doesn't know about the existence of the present SMA that are used in the industry right now. German scientists at the Saarland University have produced a prototype machine that transfers heat using a nickel titanium, that is nitinol, alloy wire wrapped around a rotating cylinder. So, if the new technology, which uses no refrigerants, proves economical and practical, it might offer a significant breakthrough in the effort to reduce climate change. In outer space work project, many space designers that are eager to create SMA devices that would work under force of the sun's heat. Like, yeah, you heard it right. Like in the outer space, we have a huge amount of heat resource, that is our sun. So suppose if we are using SMAs, that is our smart materials. So these shape memory alloys, when will be converted into any device that will be damaged by some kind of force or some accidents that will happen in our outer space on a huge numerous times. So that can regain its own structure just by application of heat. So that will be a very good advantage for our generation, for our outer space research department and research areas, where we can just regain our this damaged shape of the material just by application of sun's heat. We don't need any other kind of requirement. We don't need any other kind of support for that. Only the sun's heat will be enough to just recover the damaged surface area. So suppose there is an accident that happened, and a particular device is made of SMA, what will happen? That particular area or part will get damaged. It will change the shape of the material. But as soon as that device, that SMA built up device, gets the sun's heat from a source, so it will just regain its original shape and size. So that will be a very wonderful application for the future generation. The focus is on the new features found in traditional SMMs, namely SMA and SMPS, and a new emerging type of SMM, namely shape memory hybrid, that is SMH. So which enables enthusiasts to design SMS with tailored properties, features for a particular application without aid of experts. To do it yourself manner. So what will happen? These kind of shape memory hybrid alloys can be used or be common to the industries, right? Like right now we are using SMEs. So these hybrid materials will be more beneficial for our industry. So that can be also created in the future. So now let us discuss the various uh, fields where we are using the SMEs right now. So the metal alloys that remembers their shape and having the ability to return to the original shape after being deformed are called shape memory alloys. We already discussed that. So, what are these? These are some alloys or materials which have a special properties that we can call as smart shape memory effect or pseudo elasticity. These are two different methods that these SMAs or these smart materials uses to call back its original shape. Uh, so now there are the various smart materials. Example, smart material like NITI, copper, zinc, aluminum, and copper, aluminum, nickel. So these are the alloys that actually work as SMAs. So suppose I built a different kind of sunglass with the help of NITI or the CUZNAL. So what will happen when I will apply a certain force? The force shape of that particular device will get damaged. But when I'll apply heat on that, it will regain its original shape and size. So now going to the next topic that we discussed today is uh, the it has two semis has two stable phases. So one is high temperature phase, that is austenite structure that we already know the structure of the materials found in the material science. And then there is a low temperature phase structure that is martensite structure. So when we heat any substance like the SMAs, so the phase structure that is already present on the heated substance will be the austenite structure, and the substance which will be at a low temperature will be the martensite structure. Then their martensite also consists of two kinds, that is twinned and detwinned. The phase transformation occurs between these two phases upon heating and cooling, and is the basis of a unique properties of SMA. It's okay. So these are the things that we have already discussed, and now they exhibit very unique properties like pseudo elasticity and shape memory effect. These are the two effects responsible, and the shape memory effects are also of two kinds, like it is one way or two way, as we discussed earlier. So what is a one-way effect? The one-way effect is the one which gets damaged and can be heated only to get the original surface. But what is the two-way effect? In the two-way effect, when we cool it, it gets to the martensite structure. When we heat it, it gets to the austenite structure. We have already discussed that very well. And finally, just concluding the summary, like we have a wide variety of applications of our SMEs that is presently used in the industries of aeronautics, medical, piping, robotics, actuators, etc. Concluding to the topic. Now, we have already summarized all the topics and everything about the SMAs. So I'm sure that you have also find this information very knowledgeable and very enlightening. Thank you so much for your time. Thank you so much for your patience.